Now, on to question 6. In this case, they said by the question, and we notice a cell, and it said at the end of every year is producing a double. We started with one cell. Are we together here? That's the solution to the last year past question. That's what we are doing. Now, it said at the end of every year, that is, what is our initial number of cell? 1. You start it to one cell at every t equal to 0 at the beginning of the count, like when t equal to 0, you've not started counting at all. And they said at the end of every minute, at the end of every minute, you get, every minute there will be double, every minute double, every minute double. That is a geometric progression here, not an arithmetic progression, because it's doubling. So there is a common ratio of what? Double is what? 2. That's where we get the common ratio from. And then the period, they say we want to know after 1 hour. That is, how many minutes do you have in 1 hour? That's 60 minutes. That's our time here, t equals 60 minutes. And then someone will say, why do we use a times r raised to power t? Why do we not use naturally in your what do you call it, the formula they give you for an nth term of a geometric progression, they give us something like an equals a raised to power arn minus 1. Why we don't use that here is we use this when they give you, when your t is starting from 1, not when t starts from 0. But notice here our t begins with 0. That's the difference. You use this when you have t equals to 1 from time 1, from the first term. But this one was the first thing we have here, like the first thing they gave us here, that is when we've not started counting at all. They said initially, that is at time 0. So if you want to use n minus 1, that is, if we let's assume in this question we want to use a times r raised to power t minus 1, then we'll go and date it back to when t equals to 0, and we are not doing that. We started with when, so we date it back to when t equals to 1, but the question here, they don't give us when t equals to 1. They started with when t equals to 0. So that's why we are using the other formula, a times r raised to power t. Again, I say, when your t equals to 0, you are using this formula. Well, let's assume t equals to 1. You are using this other formula, and that will be what? A times r raised to power t minus 1. Are we getting what I'm saying? Let me come again so that you get this part so clear. They said, now after every minute, we started with 1. That is before counting the time at all. It hasn't doubled yet. You get what I'm saying? It hasn't doubled yet. And the time has not started counting. That is after the first minute, then it has doubled. So when it hasn't doubled, that was what? At time t equal to 0. Are you get what I'm saying now? So that's why we get this expression here. All you need to do is just to substitute your a equals to 1, your r equals to 2, and your t equals to 60. Then somebody can simplify this to get the answer to the question. On to the next one. Find the sum of the series 1 plus x squared plus x raised to the third power down to x raised to power k minus 1. Now, this is a geometric progression or a geometric series. Are we together? How do we know it is geometric? We notice that it is in ratio form. And of course, if you want to go back to those days, what we used to do back then in secondary school, we say, okay, take a look at it. Is there a common difference? No. Let's check the difference out. Second term minus first term, that will be x minus 1. Third term minus second term, that will be x squared minus x. Is there a common difference there? No. But checking the ratio, okay, taking the ratio, x over 1 is the same as x squared over x. Because x over 1 is x squared over x is x cubed over x squared is x. So that's where we get the idea of common ratios from. Okay, and aside that, we notice that the first term here is what? The first term is 1. The common ratio is x, and the total term here. Now, this one ends with k minus 1 because we started with 1. Are we together? And even we started with x, then it's going to end with what? The k is term. And don't forget, we have the nth term will be Tn is given by a raised to power n minus 1. a raised to power n minus 1 for geometric progression, like the nth term of a geometric progression is given by this. Compare this n here. So when it is n here, you have n minus 1 here. So we have it up to the kth term. So tk is going to be what? A raised to power x times k minus 1. And our k is what? A is what? 1. So that is tk. The kth term is actually a which is 1. A which is 1 times s raised to power k minus 1. So that's where we get the idea of that's the kth term. Now the next thing is we want to take this sum of the series. Now naturally, for us to get the sum of the series, we need to know that it is under two conditions. I get what I'm saying now. The case when it is not equal to 1 and the case when it is equal to 1. When it is not equal to 1, then definitely altogether here we use the formula. Now one thing here is this: we don't know if it is greater than 1 or less than 1. Are we together? Don't mind me. So we don't know if it is greater than 1 or if it is less than 1. So what do? For kth term, we use the formula. You know, there is a formula like this: Sn equals to a into bracket 1 minus r raised to power n and 1 minus r. That's what we use. Our first term is 1. Are we together? Are we together? So we just use 1 minus. What's our x? Substitution into this formula. That's how we get what we have here. How to get here? That is the case when x is not equal to 1. Are we together here? Now, what if x equals 1? We substitute what's our first term 1 into bracket 1 minus s raised to power k over 1 minus x. 1 here is insignificant. 1 times anything is that 10. That's how we get this one here. So that's that. Now the next thing is what if x equals 1 and we still want to take the sum of the series? When s equals 1, we still want to take the sum of the series. How will that be? I will show you how the series is going to look like now. Let me show you on a more beautiful note how the series is going to look like. Now the series is going to be, here you have 1 plus another 1 plus another 1. This is going to be 1 square, which is 1, 1 cube, which is still 1, plus 1 down to plus 1 raised to power k minus 1. Now, how many 1s will we have? We have 1 in k times. If it is 2 term, we have 1 plus 1. If it is 3 term, we have 1 plus 1 plus 1. If it is 4 term, we have 1 in 4 times. Then if it is k terms, what are we going to have? We have 1 in k times. Are we getting what I'm saying at all? If it is k terms, I want to show you on a more beautiful note how that is going to look like. If it is k term, we have 1 in k times. 1 in k times. So we say, and there are k terms. If x equals to 1, that is every term is equal to 1. Sorry, I guess I will have to make do with what I have already. Let me continue. So if it is k term, we just have, if it is 2 terms, don't forget I said that will be 1 plus 1, and that is 2. If it is 3 terms, 1 plus 1 plus 1, that's 3. If it is 4 term, that will be 4. If it is 5 term, that will be 5. That's the sum. Then if it is k term, the answer here is k. So if x equal to 1, the sum will be k, and if x is not equal to 1, the sum will be what we have here. I guess that is easy. Now on to the next question. They said the adult population at the end of year 1 is 25,000. You know, the population increase at the end of each year by 3%. Then 2 things we can say is that I will say the common ratio, that is, it is increasing. Then the common ratio is going to be what? The common ratio is going to be, now, if it is decreasing, that's how we go about it. Let's say if they are not increasing, they are not decreasing, then it will be just be the way it was, 100%. We were 50 last year, still be that same percent this year. No increase, no decrease, 50. We were 25,000 last year. This year we are still 25,000. How many of you do you come? We came 100% today. How many? Okay, I'm just taking it a good example. Let's say we are in school, and then we have 5 students, and yesterday we had 5, How many of you are present? 5. Oh, that's an 100% attendance. To the gain, how many of you are present? 5. That's an 100% attendance. No increase, no decrease. Now, should somebody leave, not be around, that will be 4/5, and that is 80% attendance. That is their 20% reduction. That will be 100 minus. So the common ratio there, if you want to take it as a ratio thing, if there is an exponential growth, it's going to be what? 100 minus 20. Now, but if one person is being added to them, that will be 1.2, the common ratio. Do you understand now? So the common ratio is going to be 1 plus, what is the actual increase? 3%. 3/100. That is where we get the 1.03 from. Now, for what to do is, all we need to do is just steal the exponential formula Tn equals A times R raised power n minus 1. Are we together here? That's still what we need to use. Now, our Pn is the Tn, first term is P1, then a common ratio n minus 1. And don't forget, they told us to find what happens to them at the end of second year. At the end of the second year. So just substitute what is the P. The P, that's the first population at the initial state, the first population, P1, that's 25,000. What's the common ratio? 1.03. And what's the number of years? 2. So substitute it. That was what we did here. Running the substitution, we get 25,000 times 1.03 raised to power what? N minus 1. And our n is 2. That's 2 minus 1. Yeah. So 2 minus 1 is 1. So that will be 25,000 times 1.03. And with that, we did a calculation. We get 25,750. And that is the solution. That will be their population at the end of the second year. What if they say the fourth year? That will be just here. The difference is going to be what? Put in 4 minus 1. The seventh year, put in 7 minus 1. And of course, simplify. You get your answer right there. Okay, good morning. Once again, on to the next one. We say, okay, now we look at the question. They give us the value. This is the question here. Permit me to do that. This is the question here. This is the question here. The question we are on to now. This is question here. A car was purchased for $18,000 US on the 1st of January. Now look at this. On the 1st of each following year. They did not say now that is this year is not the year we are beginning with. At the end of the next year. So we take this one to be at the time t equals 0. Compared to the first one we did. The previous one we did, they said at the end, that is time 1. That's why we are using the formula Tn ARN minus 1. If you are using the time when it is time 0, then you are using ARN. That's what I want to point your attention to. And that's what we are doing here. The formula we are using here is Vn equals V naught, then R raised to power n. That's the formula we use here. V naught. That is not V1. It is V1 we've not started counting at all. It is at the end of the next January. So at this current January, we've not started counting. It is after January, the next January, that will be 1 year. The next January again, second year. You get what I'm saying? So when I was okay, the value Vn, that's the value at the end of the year we are interested in. V initial, that's the initial value. R, that's the depreciation value. We notice that it's depreciating because they said it was 80% of the previous January. The next January to be 80% of the previous. 80%, not 100%. That is, the thing is actually reducing. I said if it is 100%, that's a complete thing, not reducing, not decreasing. If it is less than 100, decreasing. If it is more than 100, increasing. So this thing is decreasing. And what is the common ratio there? The common ratio is just as easy as it looks. 80%. That will be, hey, don't mind me. I guess there's an error here. There's an error around there. There's an error around there. That's a typo from me. It should have been 0.8. 0.8 all raised power 3. 0.8. There's an error around there. It should have been 0.8 all raised power 3. 0.8 all raised power 3. So please note that will be 0. Let me write in another ink then. It should be 0.8 all raised to power 3. Substitution into this formula. So our V naught is 18,000 US dollars times common ratio is 0.8. And how do we get that? That will be 80 over 100. and 80 over 100 is 0.8. Do you get what I'm doing now? So that will be 0.8 all raised by 3. Now we simplify the 0.8 all raised by 3. We got 0.512. Then multiplying it to the V, we want to get the price at the end of the 3rd January. Are you get what I'm saying? So we now see the price at the end of the 3rd January is going to be V3 times V3 equals the initial price times what this value is. So that is how we get $9,216 US. That is the value of the car 3 years after purchase is what? $9,216 US. Now let's go to the next one. The next one here is the question here. That's number 10. The value of the car in the question 9 falls below 1,000 for the first time in. You just want to know the first time it will fall below because the thing is decreasing. You know time it will fall below 1,000. You know time it will fall below what? 500. So we want to know the year, the first time. We know there will be other times where it will even fall below. In fact, later it will devalue to the point where it's almost 500, 200, and maybe something, some $7 and $5 or thereabouts. We just want to know the first time it will fall below. Don't forget, our initial value is what? Don't mind me, this some funny stuff here. That's in dollars, and we have 18, because we are using that initial question, 18,000 US. And our common ratio, we already said that is what? 0.8. Now, I want to know where it will fall, the first time it will fall below. That is the first time the price will be less than, first time it will be less than 1,000. Do you get what I'm saying? The first time the price will be less than 1,000. What are we going to do? Something simple. This is on inequality here. We already know that this is a formula guiding it. So just substitute your V0, which is 18,000. Substitute the common ratio, which is 0.08. Then all raised to power what? All raised to power n. We want to know the first time that this thing will be less than 1,000. So dividing both sides by 1,800. So at the end of the day, when you reduce this fraction here, reducing this fraction here, are we there? Reducing this fraction here, don't mind me. When we reduce the fraction right here, thank you. When we reduce the fraction here to the least form, we get 1 over 8. That's what we just wanted to do here. We are just reducing the fraction. Approximately, you notice that the value of 1 over 18 is 0.05556. That is, at the end of the day, 0.08 or raised to power n is actually less than, from the statement here, it's actually less than, good morning, it's actually less than 0.05556. And the next thing, what do we want to do? We remember that there is a law in logarithm that will help us bring the exponent down, because it is exponents we are actually interested in, not in the 0.08. It is the n we want to find. By the rule of logarithm, you know, when I have log, take the base to be c, a raised to power b, then that will be what? B log a base c. That's just the knowledge you use. And I said it earlier, at the beginning of the stuff, that if we don't put anything there, then it is in base 10. So we take what? That was what we did. Take logarithm base 10 on both sides. And that will make us what? Have what? N. The exponent now is going to come down, multiply both the logarithm and the number. And the base is base 10, of course. Of course, the base is base 10. So that will be, we take log base 10 on both sides. Log base 10 on both sides. So this one is n times log 0.8 base 10 and log 0.0556 triple 5, don't mind me, 6. 0. What we have is 0.0556. 0.0556. What we have here is still what we have here. Please note that 0.0556. So the next thing you want to do is just to divide both sides by log 0.8. Divide both sides by log 0.8. Now, log 0.05556, we got the value to be approximately minus 1.253. You can confirm that probably with a calculator. And log 0. You know how to do this kind of thing now. Standard form, that's where we get the minus 1 then. So, and log 0.80, we get that to be approximately minus 0.097. So the next thing is just divide the logarithm. So we get approximately what? 12.9 12.92. Then the next thing, when you approximately, that is approximately your 12.92 by approximation to the nearest whole number is actually 13. So the value of the car falls below $1 for the first time after 13 years of purchase. For the first time. There will still be other years. 14th year will still be below, 15th year will still be below, because the thing will keep reducing. Maybe at the 20th year, who knows? Maybe the value will have even fall to something unimaginable.